Okay. So this week we'll talk about air leakage, and we said the heat losses in a house are component of two heat losses. The first one is transmission. The second one is infiltration. So the complete heat loss of a house transmission plus transmission, we did that last week, which basically calculate the heat loss through the wall material. The other component is Q from infiltration. And what is another word for infiltration? Air leakage. So we're leaking air to the outside, and sometimes the air leaks to the inside. We'll talk about that. So I'll talk about how do we prevent air leakage, and pressure and flow. What is the relationship between pressure and flow? Why do we leak air? Why does the air escape from the inside outside or come from the outside to the inside?
The higher the pressure, the higher the flow.
So it's a pressure difference. If we have pressure difference, the air will tend to go outside or inside in order to equalize. We'll talk about blower door testing. How do we do that? What is the use for that? And how do we determine the infiltration rate for a house that's already been built? For the project and in the book, you'll see something called the infiltration loss based on the wall condition. I'll give you three types, either low, medium, or high, based on the age of the structure. It's not as accurate, but it will do the job for now. If you go to a house that's already been built for unknown material, the best way is just to do a blower door testing. And you can make a lot of money doing that because it's the ultimate test to know how much the house is breathing. And after we do the blower door testing, we can decide whether this house needs to be weatherized, we need to shut all the holes, or we can leave it as is. When do we leave it as is? Can somebody tell me? Picture will know. If we get, for example, 60 CFM, that house is 60 CFM, should we leave it or what? Insulate it.
Insulated?
Why? It's 4 people living there.
No, it's fine.
That's fine. So that house needs to have 60 CFM just to breathe normally. So okay, that's acceptable infiltration.
Right?
Yeah. If it has less than 60 CFM and there's 4 people living in that location, what do? We have to put some mechanical ventilation to meet the air requirement. So infiltration is not always bad. It's there and it's within requirement, we're good. And if we have to add, sometimes we need to add more, and sometimes we need to do some insulation. How do we find air leaks? It's very, very simple technology. It's not that high tech. So basically we pressurize the house and we go perform a smoke test just to see where the leakage are. And where do we find most of the leakage?
Windows and doors.
Windows and doors, where else?
Wall.
Yeah. Receptacles. They have a lot of air leakage. Sometimes the corners where walls meet, the corners that go to the outside, the connection might not be very sound, so you can leak through the corners. I will also watch a video about that. So there are advanced air leakage diagnostics. Some people go with infrared cameras to know where you lose most of the heat. And again, so far the best way to, if you have a small house, the best way is just to pressurize the house and go around and see where are we leaking air using smoke tester. Air sealing methods, again, very basic. You can use cold gun, you can use cold, you can use foam, you can use weather stripping, you can use, what else? Depending on what kind of openings you have. Windows need to be weather stripped or resealed. For walls, again, you can seal walls, and some walls are very, very porous that you need to insulate them with foam. You have to inject foam in it. Does anybody do any masonry? Okay. So what would you think? Air will go through brick wall? Yeah. that's one of the biggest misconceptions. People think because it's a solid wall, there's no air going through it. But bricks are very porous, so a lot of air will go through it, depending on what, on the pressure difference. The more wind you have, the more pressure difference you have. So wind provide negative pressure, correct? I'll explain that more. And that's why having chimneys in a windy day can produce negative pressure, and you start like sucking air more into the chimney, more than you're supposed to. We'll talk about that as well. So why is it important? It represents 5 to 40% of the HVAC cost. 40%, that's huge. That's most of your heat lossage going through air leakage, so it's a lot. And basically it works as air exchange. You're basically exchanging warm air with very, very cold air. So that's not really useful. We can save energy by just doing simple solutions. And we talked about the windows. How if you have all windows, single pane windows, and you put the plastic film on it, you can save up to 30% of your energy bill. We improve comfort in so many ways. Outside air brings what? Allergens, pollens, dust, whatever contaminants outside. So we rather have a well airtight house and provide our own mechanical ventilation, because we can filter it and we can control it, instead of just bringing whatever from the outside inside. If somebody outside doing some kind of work, or they're cutting the street, you'll smell the stuff coming to your house, whether you want to or not. But if you have mechanical ventilation, you can filter it, or you can close it for a slight second. It's more comfortable. You don't want drafts, and one way to find, very primitive way to find drafts in a basement or in a room that's not used is what? That's very interesting.
Flashlight.
What else? Cobweb. If you find any spider web, you know there's a hole in there. The spiders are very smart. They put their web whenever there's a draft.
Then that's for.
So that's where all the bugs will be caught. So whenever you go in a basement, look for the spider web. And probably there's a lot of infiltration over there or air current. That's why they always go with corners, right? Because the air will flow through the corner usually. So it's very simple way to detect that. Also, air leakage is not a good thing because it will ruin insulation. What does air from the outside have in it? Moisture. Moisture, after a while, depending on the weather condition, will accumulate inside your insulation, and it will ruin your insulation. What happens to the insulation if it's saturated with water? Like remember when we said earlier that if you have wood or cork as an insulator, it will absorb over time liquid. What happens if you have liquid? It will conduct electricity, and you also will conduct heat. So you fill those voids that you're depending on to insulate. And again, that's also a good environment for mold and fungi. So it's good to have appropriate air leakage. So we also reduce the heating and cooling load. That's obvious, that's the main reason we're doing it. And control moisture. Moisture, again, is an issue. Most of the houses that flooded, the most issue probably is what? Fungus and mold. And mold is really hard to treat. Sometimes the house is condemned because of the mold growth. So that's another issue you don't want to deal with. It's also reduce vermin access. If you have a lot of holes in your house, that's another access for like wasps, bees. If you have a bee's nest in your basement, you know there's a hole in there and they find out their way. Mice, they live through the walls and the ceilings and floors. So if you have an airtight house and you mitigated all the infiltration opening, probably you'll have less vermin access. Spiders as well. You can also reduce air pollution from the outside. Again, we said that before, if you have a lot of particles, if you have a lot of smog or whatever you have outside, if you have filtered air coming into the house, that is much better than just bringing air from the outside. That's unwanted. Rainwater leaks. If you have a leaky roof, if your house is not well insulated, again, the heavier the rain, the more pressure there is, you will get some leaks inside. Rain will lead to moisture, and that will also ruin your building structure. Fire safety. That's something a lot of people don't think of. Why is it a fire safety?
Fire needs oxygen.
Okay, great. So if you have a lot of oil, you're feeding that fire. So, okay, this house breathes very well, actually, from everywhere. It's not controllable, so if you have a fire, there's a lot of flow, and that will feed the fire. That's why when you have a grill, usually there are vents from the bottom to feed the fire, keep it flowing. So that's another fire hazard. Okay? So in the past, they usually do rough estimates based on the wall. They just ballpark it. Say, okay, this wall is all, we're gonna use a factor of such and such, based on the crack sizes in the wall. So if there's a crack, they measure the crack and they just ballpark whatever we can get out of that crack. So now they have the infrared cameras to know where the crack is, and you can also calculate how much heat loss you have through the infiltration. And we use the blower doors. So how does the blower door test work? Basically, it's a door with a blower in it, big fan. That fan has a lot of CFM vacuum, so basically it produces some kind of vacuum in your house, not a fluid vacuum, but some pressure difference on the outside, because the air is going to the outside. And in doing so, they have a house. I'm gonna assume it's a cube. So our door. If you put a big fan in here, going to the outside, what is the pressure here? So if we have here 1 atmospheric pressure. This is blowing out. We have negative pressure, right?
Mm-hmm.
So that will make this pressure higher than this pressure. So the pressure inside is less than the pressure outside. So what happens there? Does it want to come in?
Yep.
It's going to start to come in through the cracks. We'll have a window here, through the ceiling, through everywhere. And that will tell us where do we have cracks and openings. But it does not tell us, it
If
does not
it's
tell us.
airtight, then what you're gonna do is pull all the air out and you'll have vacuum.
You're not gonna have vacuum. It doesn't.
Not in a house,
yeah,
no.
Not enough suction power to have vacuum.
You live in space.
But the second method, the blower door just tells you where the cracks are, where all the openings are, but it does not tell you how much, which actually what we need for our calculation. So what we do is the gas tracers. So we try to see as much as we want of the house. We fill the house with carbon dioxide or some kind of gas that's not harmful, but we can trace it, we can detect it. They fill the house and they take a measurement. They leave the house, they come back in a few hours and measure how much of that gas has escaped after doing the blower door testing. So that's a good way to know how much the house is exchanging of gas. We try to find all the cracks in the house, then we would love to have a controlled air intake of the house from the proper place through mechanical ventilation and through the proper filters. Air sealing principles. So air migration requires what? Two things. If you inflate a balloon, then you put a hole in it, you have air migration, right? From the inside to the outside. What are the two things the balloon has?
Hole.
A hole, which is an opening. Second thing? Pressure difference. Thank you. So there has to be a pressure difference. If there is no pressure difference, there is no air migration. There is no motive to go for equality. Okay, well, it's all the same, so we're not going to move. And there's an opening. If there is no opening, there is no movement from one place to another. So these are the two requirements. It's also called infiltration because the air infiltrates the material and go from one place to another. And everything has some sort of porosity at some point. So no matter what, if you have a example, a balloon. After a while, that balloon will deflate. A few days by a helium balloon, it will deflate. Why? The helium actually escaped through the membrane over some time. There is some micron opening that will go through it. So unless you have some specialized metal, whatever in that container will leave. And again, at the right pressure, you can push anything through anything, especially for like plastics or membranes. And that's the basis for like reverse osmosis. If you have a reverse osmosis filter in your house, you have sheets of membranes that has very, very microscopic pores, and you pressurize it. Over time, the water molecule will go through it, and everything else will stay behind. You can even the molecules of salt will stay behind, and the filter does not go through the other side. But anyways, so we said that we wouldn't think that the brick wall, building materials and insulation are not air barrier. They are not air barrier. So you need to have some kind of plastic sheeting to have it as a appropriate barrier. And again, under the right circumstances, most things will leak. But we are, for example, sometimes you think you have an airtight house, then you go, then in a windy day, you find out that it's not. Same thing with your car. If you crack the window very, very small, or you have a hole in your door sealant, usually it doesn't bother you until when?
Winter.
You go on the highway. You go on the highway going like 70 miles an hour, and that hole becomes a menace. You'll hear it like leaking inside. Because what's happening to the pressure outside the car? Is it less or more?
Less.
Yeah? I think it's less or more?
Less outside the car?
Outside. It's less pressure. Yeah.
Because it's
So,
constantly moving.
because it's very fast. So the car is kind of an airfoil, and the air is moving fast through it, so it's less pressure, so you're losing air through your window. And if you have your AC vent open, you'll have more flow. This is going to help become a vacuum. So sometimes if you close your window vent, you'll have less noise coming from the window. So think about it similar to your house. Your house will be okay, but some openings will be a bigger problem when you have wind. So this is the stack effect. We'll talk about this a little bit. And we said that if you have air moving fast from one area here, fast air creates low pressure, right? That's why in an airplane, look at the wing, has the airfoil in it. The top part is bigger than the bottom part, right? So the air is moving faster on the top of the wing, the airfoil, which gives it what? Negative pressure. That's why we have lift. So the same thing is going here, and we have lift. So the water will rise a little bit. There's a simple experiment that explains that. We did it in 4th grade.
You did in 4th grade.
If you blow through the straight, through the sheet of paper, it goes right. This is heavy. It's not gonna happen.
Too small.
Small. Hopefully it will do it. So what I'm doing is I'm creating negative pressure, and it's lifting the piece of paper out. You can try that too. Just to help you remember that.
That's why airplanes fly.
Yeah. If you get the right airfoil pressure. So the design of the airplane we took ages, because how can you get the right amount of surface area to the weight ratio to the lift? So this is the same thing with delta P. We need to have negative pressure to pull in the water. Okay. What's a manometer? It's an instrument that basically measures the air difference, and we can do a lot with the manometer. We can calculate the air speed and the air flow. We will use that in duct system So basically, it's calculating this little flow of air that I just did. So if we put a manometer near to my mouth and I blow, you'll see the negative pressure. It will measure the negative pressure. Usually, in a manometer, it's calculated in inches of water. It can be converted to Pascal or also inches of pressure. Whenever you see inches of pressure, that's usually for vacuum measuring. But inches of water is very common for a manometer. In the refrigeration course, when we do duct sizing, we want to know the velocity of the air, so we use a manometer. So when air moves, it generates two types of pressure: dynamic pressure and static pressure. So this is static pressure. That's lifting the air up. The pressure against the flow of air, that is dynamic pressure. So knowing those two pressures will enable us to know the velocity pressure. I mean the total pressure and the velocity pressure. And that will, there's a formula for that. Based on that, measuring the pressure, you can know the velocity of air. So, in a smaller example, we have duct system. We have air flowing through it. If we put a manometer here, what do we get? Static pressure or velocity pressure?
Velocity.
No, it's in the side.
Oh, okay.
That's gonna be static pressure. I know it's confusing. And if we put a tube in here, facing the other way,
That's velocity.
this is velocity pressure. Actually, I'm wrong. This is total pressure. Because this is also getting some static and also getting velocity. So, what do I need from that? I need velocity pressure. So total pressure equals static plus velocity. So I get the velocity pressure out of the total pressure from here, and the static pressure, and this is how I get the velocity of the air. This is one way to measure the velocity of the air. The other way is to get a cone, big cone, and you stick it in the duct, and that will calculate for you the velocity of the air. We'll do this in more examples and go into the duct design for heating. But for now, all you have to know is a manometer will measure the pressure of the air moving inside the house. This is what it looks like, also known as a pressure meter, and it has different units. Sometimes it's Pascal and sometimes it's inches of water, and they are converted from one to another. So again, we said the wind pressure. So imagine wind is being blowing over the piece of paper, and the pressure is coming from the bottom. So the wind pressure is pushing against the wall, and that's going to be total pressure. But it's also creating some kind of a negative pressure on the entire house. So it's going to be positive pressure, and it's going to be a vacuum because there is flowing over it, and there's a vacuum in this area over here. I don't want to get too much into it, but it kind of makes sense a little bit how the pressure goes through an object and create a vacuum. And that's force over here. Here is called drag. So if you see big trucks in the highway and they have those deflectors in the back, what they're trying to fight is the drag forces over here. If you play golf, you notice that the golf ball has what in it?
To reduce its drag so it can fly further.
If you don't have those holes, those dimples on the golf ball, you won't go as far. The drag will pull it back. So you need that to fight the drag. And how do you do that? You fight smooth surface, because smooth surface enables separation between the airflow. I'm not going to get too much into it, but probably if you notice these things. Most trucks, actually, they put those deflectors in the back to fight drag, and that will, if we fight drag, what will happen to the fuel efficiency? if you find it, if you have drag, it will slow you down. So you try to minimize the drag. You're always going to have drag, no matter what, but try to minimize it. So your house at some point when there's wind blowing at it, there's always going to be a drag force over here, and that's performing some kind of suction. Okay, we'll finish this up on Wednesday. Here's some questions.